guys, this is Wojtek, and today we're going to take a look at adding in some widgets, specifically to allow us to create combos with little animations as we interact with our environment by hitting it. To accomplish this, we're going to override the HUD class and have it be sort of part of our default game mode. We're also going to create a new user widget that's going to contain all of this combo information. And then lastly, we're going to manipulate our widget using widget animation elements. So let's get started. All right, folks, so let's get right into it. We're going to go ahead and create a couple of new classes. We're going to create a new HUD class and a UUserWidget class that we're going to then extend for our UI components. So let's just go ahead and do that before we get started. So I'm just going to create a new class, and this is going to be part of our HUD. So it's going to inherit from HUD-H. And we're going to drop this into a new folder called UI. And we're going to call this guy, it's going to be in-game HUD. So it's going to be the primary HUD for all of our, health bars, combo, attacks, and sprint, stamina measurement, and all of that good stuff. So let's go ahead and create this class. It's just going to take a second. Okay, so we have our class generated, and now let's just go back to the editor for a quick second and generate our user widget class as well. So the HUD class is going to be our container of widgets. So think of it as sort of as the holistic representation of all of our UI components, and the widgets are going to be the individual pieces that comprise our various functions. So we're going to look for user widget as our base class. There it is. And again, let's drop it in the UI folder, and we're going to call this guy our ComboWidget. So there's our class. All right, so we have the two classes we're going to be working with, and we're going to start off with our ComboWidget class first, just because in-game HUD inherits it, and our player character is going to inherit the HUD. So we're going to work in order this time. And first things first, we want to create a constructor. So this is going to be our ComboWidget constructor. The only thing we just have to be aware of, and sorry, this is a new ComboWidget, is that the default constructors for the widget components are not actually empty. They take in a const of FObject initializer. So just make sure to include it as an input parameter, otherwise you will get compilation issues. If you're ever curious as to what these method signatures that you're overriding look like, you can always step into the actual base class for user widget and start poking around. Let me just show you real quick. So you can see there's our user widget constructor, and there's a handful of methods we can overload and implement within our user widget implementation. So one of the ones we're going to look at later on is things like native construct and a couple of other ones in order to do some various functions. But for right now, we're just going to focus on the constructor right here. So let's go back to our widget. So we have our constructor, and that's pretty handy. And now we're going to do a couple of things. So we're going to create a method that allows us to update the count of our hits, of our combos. So I'm going to create a new method called just update combo count, and it's going to take a integer as the value. We don't need anything fancy for that. We're also going to create another method on this widget that allows us to reset the count and perhaps perform some other operations on our combo definition. So this is just going to be called reset combo, no input parameters, just a straight up function. And I think we're going to stick with this for right now. We're going to get into a few other things very, very shortly, specifically the widget animations, but let's just flesh out our component first. Make sure it draws on the UI and all of that good stuff. So the other things we need to start adding are the components of our widget that are actually going to represent our combo information. So in this case, I'm going to create a new property. It's going to be edited anywhere. I'm going to say blueprint read write. And we're going to use this interesting little meta tag, bind widget. And I'll include the links to more documentation about this, but this is one of those little hidden features of the UMG components that basically allows you, by name, to bind a property to the actual representation on the widget. So instead of instantiating, let's say, a text box and then sort of retrieving it from the widget and populating it locally so we can play around with it, we can simply say, uTextBox and bind widget is going to automatically look for this type of element on our widget with this name. And I'll show you in the blueprint when it complains about not being able to find this. Now, I will also include information on how you can traditionally sort of generate these text boxes, but for the purposes of our exercise, this is way faster to work with. It's a little bit unintuitive, as you just need to be aware that this guy does a little bit of magic and auto binding. But once you kind of get comfortable with it, it's a nice little feature. Thank you to a gentleman on Reddit who recommended this feature. I will make sure to credit you in the blog post. Okay, so we have our combo, we have a couple of methods, and we have our initializer. So far, so good. So let's go ahead and go into the CPP file and now just start adding in some of these details. Okay, so our ComboWidget, and there's our constructor. So we're going to leave this empty for now. Now we're going to go and add in our update combo. ComboWidget update combo count and 32, and we'll also do our ComboWidget on reset combo. Cool. So there's our methods. So far, so good. We're also going to include. Just make sure that's right. Yeah, that looks right. What else we're going to include in here is another method, because we do need to be able to initialize something similar to begin play. So we're going to use the native construct method, and we're going to override this guy. Sorry, I completely forgot about it as I was yapping here. So virtual void native construct, we're going to overwrite this method. And this is going to be used as essentially as our begin play. We're going to make some initialization directives within this guy. I'll show you in just a second. Okay, and we're going to drop this guy right below the constructor. Native construct. Okay, and always make sure to call your super methods, since we're all dealing with inheritance here, so things don't go wonky. Okay, so update combo count. What do we want to do in this method? Well, we want to bring in our text box. So we're going to say if txt combo is valid, and we also want to say if value is greater than 1, because we don't necessarily want to display any information for a combo if I'm just coming in with, let's say, a single hit. So I'm just going to protect myself right at this particular level and go from there. So the other thing we're going to do is we're going to say txt combo and my autocomplete is not working because I did not include our UMG header. So you'll notice this data type was not being recognized in my IntelliSense because I was not bringing these header information, so I had no way of understanding what uTextBox was. Now it should be just a little bit better. Maybe not. Now this could just be slow IntelliSense in Visual Studio, which I'm sure we are all used to. So it's set visibility, and we're going to set the eSlate visibility to visible. basically what we're doing here is every time we update the combo, we're just going to turn this guy on if our combo box is not visible. So isolate visibility, hidden. Okay, so turn text box visible if already hidden. Okay, so far so good. Let's go ahead and keep expanding our logic here. So once we have our text combo visible, what we want to do is we want to say set text, and we're going to bring in our value as part of that output. So what I'm going to do is I'm going to say ftext from string, and we're going to bring in our integer. So we're going to say where is int from it. There it is. So we're going to bring our value, which is going to be the first value, and then we can simply say plus x combo. Generate output like 2x combo. And now we've got some additional information there. So let's now take a look at the reset combo method. And what this guy's going to do is basically say, hey, if our text box exists, our txt combo set visibility to hidden. So after we finish doing our combo operation and our player is finally done doing stuff, we're just simply going to reset this guy and call it a day. And I did forget to also include super initializer, object initializer, which is why this guy was complaining. Okay, so there is our widget definition for now. And now let's go ahead and start adding in some more details to our HUD object. So the HUD object is going to be the container for all of our widgets. And similar to our widget, we're going to say a in-game HUD and generate our constructor. Now this one doesn't take any parameters by default, so we're just going to leave it as is. Now we're going to override a couple of these methods in the HUD class. So let's pull this guy up and just take a real quick look here. So I'm just trying to find them here. Where is it? Draw rect, draw texture. There it is. So we're going to overwrite draw HUD, and as the comment here says, it's the main loop for the HUD. Gets called before any messaging and should be subclassed. So you want to include this method. This is where a bunch of your sort of rendering details are going to go into. The other ones we're going to override is begin play, tick, just for for posterity. We're not going to include anything in the tick right now, but we'll just have it later. We'll just have it available for later use. So let's go ahead and override our draw HUD method. We're going to bring this guy in. We're going to override our begin play. And we're going to override our tick. All right. So on here, we're also going to add a new function, which is going to look almost identical to our widget function. It's going to be called update combo count. I'm sure you can guess it takes in our combo value. So we have that. We're also going to include a header definition for our widget components. Widget component. There we go. Otherwise, our compiler won't recognize things. And we're going to bring in our U property. And defaults only. category is going to be widgets, and we're going to say T subclass of UUserWidget, and we're going to call this our ComboWidget class. So this is the parameter that's going to let us assign our ComboWidget onto the HUD, which will then, take care of rendering and displaying it appropriately. The other method I forgot to include is our reset combo. And again, this is just a helper method where our player can interact with these HUD values while the HUD updates all of our widget information. So lastly, we're going to add in our we're going to bring in our ComboWidget, and we're going to create a private variable that is then going to be instantiated based on this class being available to our HUD object. Okay, so similar to our ComboWidget, let's go ahead and flesh out the in-game HUD CPP file. So I'm simply going to instantiate our our constructor, and again, it's not going to do anything for right now, but we want to make sure all this stuff is available to us. And then we're going to say and get our begin play sorted out. Again, with any methods you're overwriting, ensure that you call the parents method. Otherwise, we're going to have some weird issues. So in begin play, we're also going to instantiate our widget object. So we're going to say if our ComboWidget class is available, we can then say ComboWidget equals create widget of type UComboWidget, and we're going to pass in. So this guy actually takes two parameters. I don't know, I hit print. So this guy actually takes two parameters. If you look at the object definition, so the owning object, who is going to be the owner of the spawned widget, and then what is the class, and perhaps we can even pass in the name. But we're going to ignore the name for right now. So we're going to spawn this in the world. That's going to be our owner of this widget. And then we're going to pass in our ComboWidget class as the other input parameter. Now, if this all went well, then we can say ComboWidget add to viewport. And we can also define the Z order here. So you have widgets that overlay each other, and you want, let's say, the ComboWidget to be on top of the health widget or something like that. This is where you would adjust the Z order to make sure that things are sort of layered accordingly. Okay, so this should now take in our widget if available and instantiate it. So we're kind of done with the begin play. Now let's go ahead and add in our tick. And the tick, again, super tick, pass in our delta seconds. And we're not going to do much here yet. Likewise with our draw HUD method, we're just going to leave it empty and make sure we pull super. All right, we're just zipping straight along through this example. All right, now come the actual methods that are going to allow us to do some stuff to our UI widgets. So we're going to create our update combo count, takes in our value, and we're simply going to say if ComboWidget update combo count, and we pass in our value. So you can see just, we're using this HUD as a bit of a proxy to our actual widgets. And we're going do the same thing with our reset combo. If ComboWidget reset. Okay. So I'm just going to recompile everything, make sure there's no weird exceptions, and we're going to move on from there. Yeah, and see, this is what happens, folks, when I don't pay attention and just yap through as I'm typing away. So the reason our U text box was not actually compiling is because it's U text block. A little bit better. So then this wonderful error can go away. All right, let me recompile and see what else we broke along the way. All right, so we're all recompiled and good to go. I won't bore you with a couple of the spelling mistakes I had in here, but visibility, set visibility, and object initializer were all missing I's. And, you know, my ESL was kicking in, so let's let's move on from here. So we have our widget, we have our HUD. We're going to go ahead and now implement a widget so we can see that this is actually working. And that it's actually going to not blow up anything in our game. So I'm going to create a new UI folder. And here what we're going to do is we're going to create a couple of new blueprints. So we're going to create a blueprint for our HUD. So if we look for HUD now, we should have our in-game HUD object. So we're going to get this guy, and it's going to be BP in-game HUD. And if we crack this guy open, you know, there's not much going on. Our class settings, have our parent class, and you know, it's pretty barren, and that's okay. We're going to be doing all of our work in C++. And we're going to add another blueprint that represents our widget. So if you look for widget now, you'll notice there's our user widget and ComboWidget inherits from it. So again, pretty good. ComboWidget. Okay, now to include these guys within our actual game, what we want to do is go to Settings, World Settings, and depending where your pane opens up on my screen, it's on the right-hand side. There's a couple things going on here. So there's a game mode, and there was a collapse section under Select Game Mode that had all this stuff. And you'll see one of these things is our HUD class. So through our game mode, we are able to flip our HUDs around, but in order to do this, we can't select it. It's gray, so we actually have to create a game mode, just a very generic one. So what I'm going to do is I'm going to create a new blueprint, and it's going to inherit from our generic game mode that came with the project, and we're going to say BP game mode. Now, all this really allows us to do is from the drop-down, now to select BP game mode, and we can now modify these values. So we don't care about all this other stuff for right now. We're going to look at states and player states and controllers, all that good stuff. But for right now, we're just going to simply flip our HUD class to BP in-game HUD. Excellent. So one thing done, but if we start our game, there's still not going to be anything on the screen because we haven't actually created our widget definition. So let's pop open our widget, and you'll be presented with this this screen that has sort of the default screen size. You see it's 1280 by 720. DPI, you can make all kinds of adjustments to support the screen orientation that you need. But more importantly, here is that warning I mentioned previously. So you'll notice this widget expects TXT combo to be available to us with a specific type because we have it marked here with that bind widget, annotation, decorator, whatever you want to call it. But it's there, and it's forcing us to now implement TXT combo. So I'm simply going to take a text box, or a text block rather, sorry, and I'm just going to drop it somewhere here on the screen. Yeah, you know, let's go with that. We'll go with that one. And this guy's going to be called txt combo. So now, when I recompile, oh, why is it failing? Txt combo. Oh, sorry, that was the text. Yeah. Not the name of the property. There we go, and this is going to be sample text. There we go. Sorry. So once we have that recompiled, you can see, hey, we have our stuff available to us, and our text is in the top left-hand corner. We should probably move that somewhere else, I'm thinking. Oh, you know what, let's just leave it there for now and make sure everything works. So nothing is rendering on the screen. Just make sure we save this all. We got our game mode, and on our HUD BP, the only thing we're missing is our ComboWidget class. So that was something I forgot to set. So on our HUD, make sure we reference our ComboWidget. And now, when we start our game, there we go. There's our sample text in the top left-hand corner. Pretty good. So now let's go ahead and actually make that text do something. Let's have it update as we punch things and interact with our environment. Okay, so to do so, what we need to do is go back to our player character, and within our player character, we're actually going to sort of get at the HUD. And what we're going to do, where in the heck is the player character? There we go. So what we're going to do, on our attack hit, so let's find our on attack hit, there it is. Basically, after our montage gets kicked off, we're going to make a call to our HUD and say, you know, increase it by some amount. So to do that, we're first going to create in our player character a property of current combo count. You know what, let's just go, yeah, let's go current combo count, because then we can also have, you know, highest combos and things like that. And this guy is going to be initialized with a value of 0, just to be on the safe side. No one's going to be allowed to override it. We're simply going to use it to increase our combos and then sort of reset them later on. Okay, but we also need to worry about resets. So let's get our value going in first, and then we'll look at how to reset it. And we're going to use actually our timers from our previous tutorials to handle that. So if you don't hit the combo within a specific amount of time, then obviously you cancel the combo and then you have to restart again. So let's go back to our on attack hit, and what we're going to do is we're going to use the world to actually bring in our HUD. So, sorry, I forgot to include the header file for our HUD. So, we're going to say UI in-game HUD. All right, on attack hit. Let's go back to this guy. So, right after our montage plays, we're going to say in-game HUD, and what we're going to do is we're going to cast it from get world, and then we're going to say get first player controller, and then we say get HUD. One thing to note about this execution is this implies you have access to the local controller. If for whatever reason this type of call is being made from the server, you need to account for the fact that you may not have access to the player. And there's different ways of obtaining that information. So just something to keep in mind when you're dealing with multiplayer type implementations. But for our particular case, this is going to work just fine. So we're going to make sure our object is initialized, nothing worse than null pointers. And then we're going to say current combo count by 1. So every time we connect with our punch, we're going to add 1 to our combo count. And then we're going to say in-game HUD update combo count. And there's our current combo count. Pretty straightforward. Now, resetting. So let's go ahead and add in a timer. And we'll drop it right here after the excuse me, current combo count. So we're going to create a new ftimer handle, and we're going to call this combo reset handle. So back to our on attack, we're going to say if get world get time manager is timer active. So if it's active, or sorry, if it's not active, what we want to do is actually kick it off. So get world, get timer manager, and we say set timer, pass in our handle, pass in sort of this object. Now we need a callback function. So what I'm going to say before we add this is just our character and then reset combo. We'll add this method in just a second. Our rate is going to be 1f. That's how we're going to play it back. It's not going to be in a loop. And our first delay, I don't think we're even going to worry about that. Yeah, you know what? We'll just leave it at this. Did I put that in for timer handle? Sorry, I'm just making sure I have all of my properties correctly set up. There we go. Loop false. Okay. Now, if this timer is already playing, what we want to do is we actually want to, let's take this, and we want to clear it. So what I'm going to do is just say get world, get time manager, clear, and then pass in my timer handle. Now let's go ahead and add this reset combo method in our player character. So it's going to be a we'll do it. We'll do a public. So we're going to say u function and just reset combo. Let's go back to our player character. And, you know, I'll do it right below this. Okay, and there's reset combo. So what reset combo is going to do is a couple of things. It's going to, by default, reset our current combo count to 0, and it's also going to make a call to our in-game HUD. So again, I'm just going to make a call to in-game HUD. Get first player controller and then get our HUD. Now, because I'm making this this cast call a couple of times, there is opportunity for you to create a little helper method, you know, that always gets you the HUD, and then you just make operations on that rather than, you know, sort of constantly messing around with the casting. And then we're going to say in-game HUD reset combo. Oh, and we're missing a semicolon there, which is why that if statement is freaking out. All right. So, if all works well, what should happen after we recompile this is whenever I make a hit within 1 second, we should basically reset our combo count as we update it, when our character punches. So maybe, now that I'm thinking about this, maybe 1 second is too long. So let me change this too short to 5 seconds, and then we'll recompile again. Let me just cancel my bill here. All right, let's try this again. All right, so our project is recompiled. Let's see what this looks like. So there's sample text still showing. And now anything past my initial hit is updating my combo count accordingly. And within a couple of seconds, you'll notice things got reset. So let's wait a few seconds, and bam, it's gone. Cool. So this is kind of how you implement a combo system. So our player character is counting our hits. Our UI is, gently picking up that information depending on what happens and updating your combo count. So what else can we do with this? Why don't we add a couple of animations that make the presentation of our combo just a little bit more exciting. So I'll add a little bit of a shake, a little bit of a wobble, and a little bit of a fade out as we're counting down to the combo reset. Whereas right now it's kind of jarring, right? Nothing happens, we don't know what's going on. Oh, there's a combo, and within a few seconds it goes away. So to do that, what we need to do is look at UWidget Animation. And you'll notice on your ComboWidget blueprint, one of the things we have available to us is this animation section bottom left. So if we add this animation, or if we add a new animation, what this allows us to do is control the elements on the screen. So let me go ahead and just spend a few minutes prepping this, and I'll walk you through kind of what we have going on here. All right, folks, so I got my my text box all cleaned up, and now let's just go ahead and make sure that it's centered when we display this information. We'll do it right kind of in the middle of our screen. And then let's style this text box just a little bit. So, why don't we use a slightly darker color. Let's give our font just a little bit more visibility, so maybe 48. That seems like a good size. I'll pop it here in the middle, more or less. And let's set our justification to be centered. We can also add additional fonts, but I don't really have any ones included right now, so we'll leave that for another exercise. And you have also things like shadow offsets, right? So, if you want to have, can't really see, but if you want to have a little bit of a shadow going on with your, with your guy here, you can mess around with, the various shadow colors and things like that. But I think we're good for now. We'll leave this as is, and I'll show you now what these animations end up looking like. So I'm going to add a new animation called Combo Fade. And what this animation is going to allow us to do is basically fade out this text over a period of time. So our reset is about 5 seconds. So what I'm going to do is I'm going to make our text fade over 5 seconds as well. So you'll notice here's your timeline. And for folks who have never worked with animation software, they're all pretty much similar in the sense that you have tracks, and a track represents sort of a layer of activity. And on that track, you can perform various operations, and you can have a whole pile of these. So in our case, you'll notice if I'm just clicking on the canvas panel behind, the track is picking up canvas panel as the input. If I click on my text box, it's picking up text box as my input. Or oh no, that doesn't work. I thought perhaps we could drag it in, but that's just for for the sequencer within the level editor. So let's go ahead and select our text box, track, txt combo, and there is the thing we're going to do an animation on. Now, further to the individual tracks, there's all the different sort of properties that then become available to you for your animation purposes. So in our case, we're just going to look at color and opacity. So what we're going to say is these are our default values. So we have 1, you notice they represent our colors. So 1 for the red, 29008 for blue and green, and then our alpha is 1. So what we want to do is we want to add a keyframe at 0 seconds before this animation starts. And then at some point in time in the future, so let's say we do it over 5 seconds, we want to add another keyframe that's going to change our alpha from 1 to 0. So now, when we play our animation, our text is going to gently fade out over those 5 seconds. Basically keeping in line with our timer of resetting the combos. And there's some inaccuracies with this. You can tie it, together so everything operates off of one timer, but for our purposes, again, we're not gonna do that. But yeah, there you go. This is how our alpha is going to fade. And then we're going to add a secondary animation. And we're going to call this combo shake. And what this guy's going to do is, so we're going to add another track. And we're going to do this for our transform. So we got our translation, our rotation, our scale, etc. And we're going to add our first keyframe, basically saying, yep, don't do anything. And then maybe within, let's say 0.1 of a second, we're going to add another keyframe. But in this case, we're going to change the X to be 5 and the Y to be 5. So it's going to go to the right and down a bit. So you can see how it kind of wobbles. And we can even add a rotation of maybe, I don't know, 15. That's maybe a little too aggressive. Let's do 5. So it's going to go like this. And then at 0.2, we're going to reset our angle to -5. We're going to set our Y to 5 and this to -5 as well. So it's going to kind of do this little wobble thing. And then another 0.1 of a second later, we're just going to reset things back to what they were. So now with every hit, we should get this little wobble going. Just kind of showing that combos are actually being, executed. And you can add some, variance and randomness to this, so it doesn't always pivot the same way. But for our purposes, we're just going to stick with this. Okay, so we have our 2 animations. And now we need to reference them within our code. So how do we go about doing that? Let's pop open our class definitions, and we're going to go to our widget class. Where is our widget class? ComboWidget. And we're going to take a look at this guy here. So let's create a couple of private member variables. One of them is going to be, or actually both of them are going to be UWidgetAnimations. Our first one's going to be combo fade. Our second one's going to be combo shake. Actually, you know what? Animation. Just because you want to be explicit with your variable name definitions. And for the most part, this would be cool if we could use the same sort of binding that we did with our uText block. but we can't with animations. In fact, animations are a little bit of a pain in the ass to work with because we need to get all the properties of the widget and then cast them accordingly to the widget animation. I think there's a ticket around getting bind widget for other components of the UMG elements, but as far as I know, this is still not implemented. So let's be good scientists and create a little reusable method that we can then reference for any other animation we choose to add. So there's a couple of interesting little tutorials floating around the internet of how this is done. I kind of took the best of both worlds. And basically what we're going to do is at application or game start, we're going to fill this map with all of the available widget animations for this widget. And then by key or by name, we can reference those animations at runtime for playback, resetting, etc. But to do that, we need a little method. So we're going to have this method called, it's going to return a widget animation, and we're going to say get animation by name, fname, and it's going to be our animation name. It's a const, and we also need another little method that fills up this map. And this is why we have the native construct, because when this widget gets created, this guy's going to call our store widget animations method, and then we can have access to them through here. So let's go back to our ComboWidget. Now I'm going to say ComboWidget store widget animations. And what this guy's going to do is a little bit complicated in a way, but not too hard to understand. So we're going to empty out the map just to be on the safe side in case we call this method from other points in our timeline. And then what we're going to do is, we're going to get all of the properties from the current class we're working on. Property link. There it is. Okay, and let's do a little bit of checking. If prop get class equals UObject, UObject, where is it? UObject property. There it is. So we only deal with object properties because there's other ones on our widget, but we really don't care about those too much, at least not in this exercise. So we're going to get our UObject property and we're going to cast it from our prop. Okay, and only get properties that are widget animations. So we're going to say if obj prop get class and you know what, let's not use the equals, let's use the is a. You know what, we'll leave it as is. Okay, so there's our get class, and we have our widget animation. So now we can actually do a little bit of conversion on this. So you want to say UObject, because that's the base object definition in the engine. I'm going to say object prop get object property value in container. and the container is this. So this should now give us our UWidget Animation object that we can then do a little bit of work with. So there's a UWidget Animation. Widget Animation equals cast animation. Okay, so if our widget animation is now available to us, we can go ahead and do some stuff with this. So we're going to say fname name equals widget animation movie scene get fname. And actually, you know what? Let's because we're calling movie scene, and perhaps that is not filled up yet. If you recall, you can have an animation, right? So we add a new one without any track information. So this is just an extra little null check to ensure that we have some information we can work with. Okay, so there's our name, and then we can say animations map, add anim name as our value, and then the widget animation, or sorry, anim name as our key, and the widget animation as our value. And the only other thing that we're going to do here, oh, sorry, I thought I already had the loop definition on this. So sorry, all this code is actually going to be in a while loop because there's more than one property. So while our property is still available to us, we're going to do this work, and then we're going to say prop equals prop next line. So basically we're iterating over all the various properties and ensuring that we fill in our map. Okay, so this will give us all of the widget animations. Now we can go ahead and create a little helper method that's going to bring back a specific animation for that value. Get animation by name, and we're going to pass in our fname. So now we simply say UWidget Animation. And we're going to make this guy a const. Widget animation equals animation map dot animation map dot find in our animation name. All right, and if our widget animation is kosher, return our widget animation, otherwise return a null pointer. Oh, right, this has to be a pointer. And what is this guy complaining about? Is compatible. UWidget get animation by name. Oh, right. Because we want to make it a constant. Okay, so there's our animations. There is the map. And now we actually want to play these guys back as things are being updated. So what we're going to do is we're going to say if combo fade animation. Then we say play animation, which is a built-in method, and you'll notice it takes in our animation. So combo fade animation. Our start time is going to be 0, so right at the beginning. We're only going to loop this once. Our play mode is going to be forward. And there's different ones, as you might have noticed, ping pong and a couple of other ones, backwards. And our playback speed is going to be 1f. So just forward at a constant rate. And then we can do the exact same thing with our combo shake animation. Play animation, combo shake animation, F1, we're going to say forward, and 1 for the actual playback rate. All right. And finally, in our native construct, which is, again, similar to a begin play, we want to call star widget animations. So when our widget gets instantiated, populate the map. And then we want to say, oops, combo fade animation equals get animations by name. And we say combo fade. And then we say combo shake animation. And we pass in combo shake as the input. Oops. All right. Let me just double check, make sure everything is in place, and let's recompile, see what this looks like. All right, guys, so we're all recompiled. Let's take a look what this looks like now. So there's our text block right in the center. And when we hit, oh, our shaking is not working. And it's not working because get class. Oh, sorry. This is supposed to be property class, not get class. The other thing I also added in was just a little message after a second recompile. And to do that, you need engine H. I just wanted to print out the actual animation names that were being rendered as this widget was being instantiated. So let's recompile and just give it one more shot. All right, let's see what this looks like now. So what we should see is in the top left-hand corner just a few messages showing the, oh, there we go, combo shake and combo fade being loaded. And you know what, let's get rid of the default text block so it just looks a little bit prettier. Okay, so there's our animations. We just loaded them from our widget there. And there we go. As we punch, you'll notice our little combo counts up and shakes a little bit, and as I step away, it just fades out gently into nothingness. Cool. And then if I were to, kick around again, boom, our combos are reset. If I catch it just sort of as it's beginning to fade, I still have a little bit of time to resume my combo, so you see it kind of comes back. All of our timers are being nicely reset. And we generally have, little basis of a combo mechanic. We can now start using these values to multiply our hit points, critical hits, and all kinds of interesting stuff. You could even, have different animations and colors and, changes to the UI widgets as these things occur. So, as you guys can see, it wasn't too bad to generate these combos, and I hope you tune in next time when we start looking at expanding our game to include, health and sprinting and crouching and various other movements for our character to interact with in the world. So, thank you for tuning in, and hope to see you guys next time.